Welcome back to the channel. In today's video, we're diving into policy-based routing, also known as PBR. If you've ever wanted more control over how your traffic flows through your network, beyond what your routing table decides, then PBR is your new best friend. Let's dive into it. Policy-based routing lets us override the normal routing process. Instead of the router making decisions only based on the routing table, PBR allows us to route traffic based on policies, like source IP, destination IP, protocol, or even application type. Think of it as the saying, "Hey router, I know what your routing table says, but for this specific type of traffic, send it over this path instead." That's PBR. So why would you ever need to override the routing table? Here are a few real-world reasons. You might want certain users to take a different internet connection for load balancing. Maybe guest traffic should go through a slower path while business traffic takes the fast premium path. Or you might have a backup MPLS circuit and want only voice over IP to use it. Routing tables can't do that alone. They don't know who generated the traffic, they only know the shortest path. PBR opens the door to routing based on business logic, not just metrics. Here's the picture of how PBR gets applied. 1. You identify the traffic with an extended ACL. 2. You match that traffic inside a route map. And 3. You then apply that route map to an interface, usually the LAN-facing interface where the traffic enters. So the workflow is define with an ACL, match within a route map, and apply on an interface. I'm going to go over command outlines you're expected to know for PBR. Number 1, create an extended ACL. Number 2, create the route map. And number 3, apply it to an interface. These 3 pieces make the entire PBR configuration work. Let's break down the meaning of these commands. IP access list extended PBR traffic. This creates a named extended ACL where we define the traffic we care about. Permit IP, source, wildcard, destination, wildcard. This line says, match traffic from this source going to this destination. Route map, PBR map, permit 10. This creates a route map entry that will let matching traffic be processed. Match IP address PBR traffic. This tells the router, use the ACL to identify which packets this route map must act on. Set IP next hop IP. This is where we override the routing table and tell the router exactly where to send the traffic. IP policy route map, PBR map. This applies the route map to the interface, meaning incoming traffic on that interface will go through the PBR. In this example, let's say I want all traffic coming from 10.10.10.0/24 subnet to take a special path with a next hop of 192.168.2.1. The ACL identifies that traffic. The route map says, if this is the traffic we matched, send it over to 192.168.2.1. And once we apply it to G00, the router begins enforcing that policy. This is the simplest and cleanest form of PBR. Before we move on, let's quickly lock in the key terms used in policy-based routing. PBR. Policy-based routing is the process of forcing a router to make routing decisions based on rules we create, instead of relying only on the routing table. ACL. An ACL is used in PBR to identify traffic. In this case, it's not being used to block traffic. It's being used to match traffic so the router knows which packets the policy applies to. Extended ACL. PBR uses extended ACLs because they allow us to match traffic based on source and destination addresses, and optionally protocol and ports. This gives us precise control over which traffic the policy affects. Route map. A route map is the logic engine of PBR. It takes the traffic matched by the ACL and defines what action should be taken, such as forcing a specific next hop. Set IP next hop. Set IP next hop completely overrides the routing table. If traffic matches the policy, the router must forward it to the specified next hop, regardless of what the routing table says. Set IP default next hop. Set IP default next hop is a conditional override. The router will use the policy's next hop only if the routing table doesn't already have a valid route. If a route exists, normal routing is used. Inbound interface. Policy-based routing is applied inbound on an interface. This means the router evaluates the policy as traffic enters the interface before the routing table is consulted. Normal routing table. The normal routing table is the default routing decision process. Without PBR, routers forward packets strictly based on the best match in the routing table using longest prefix match. If you understand these terms, you understand the foundation of policy-based routing. Let's recap everything quickly. PBR overrides the routing table. It's used when you want specific traffic to take a specific path. You build PBR using 3 parts. Number 1, extended ACL. Number 2, route map. Number 3, apply to interface. The ACL identifies traffic, the route map tells the router what to do with it, and the interface command activates the policy.